So today we will be talking about the chemical reaction second part. As in the first class, we have discussed up to the states that how do you display the states of different substances. Like if it is a solid, liquid or gases, then how do you represent that in case of an equation, right? But we have not discussed about that if you're having some catalyst or if you're talking about any condition, let's say if you're having some sunlight or you're providing some heat, then how are you going to represent that? Or maybe some pressure conditions are there. So how we will be talking about that and how do we represent that? So I'll be extending this topic forward now. I hope the first part of this chapter is already clear to you all. And now I can proceed further with this one. And please make sure that you all like, share, and subscribe to my channel for the next parts. This is the second part, and I think 2 more parts, and then this chapter will be finished. But the NCRT part is finished, not the questions. We'll be discussing all the NCRT questions here, all the text questions, and I will bring some very interesting questions which are not there in your NCRT books, and some of the questions are not there even in your reference books. So the questions which we will be practicing here will be super good and of a very good level. So please make sure that you all hit that like button for more updates related to the classes. Now let's get started. Now in this equation, you all can see carbon monoxide is there, and we are heating the carbon monoxide in the presence of a hydrogen gas with a pressure of 340 atm. Always remember, pressure is either measured in atm or in bars. Okay, so we are applying a pressure on the hydrogen gas so that hydrogen can react with this CO gas, and it is going to make an alcohol here. And which alcohol? Methanol. Should I tell you one very interesting thing about this methanol? You know, in earlier times, this methanol used to be used for the paint, like painting of the walls and painting of the tables and the almiras. And but in big industries, they used to contain this. They used to have this, not methanol. This one they used to have earlier. But later on, because this is drinkable, so what the workers started to do, they started taking it home, they started drinking it there, and then the companies were seeing that we are getting a very big loss because of this, and these workers are not concentrating on the work, they're drinking this alcohol to the present time. So what they've done is they have added a denaturated alcohol to this drinkable alcohol. Okay, so they have made it unfit for drinking. So this is methanol, which is unfit for drinking, and if anybody by mistake drinks it, it is very dangerous for health. And that was the reason they have added this ethanol, which is drinkable, with this methanol in the paint industries, and wherever it is used, they add for the denaturation a little amount of methanol. Okay, so yeah, that was the fact related to this. Now let's concentrate what we were studying. Yeah. So this is methanol. So when you're having carbon monoxide pressurized with hydrogen gas, always remember the product will be denaturated alcohol. And always remember that ma'am has told us this thing related to methanol at this particular time. So you will never forget this equation. Okay, so now in the next equation, okay, before we move to the next equation, you all can see we have mentioned this pressure over this arrow. So always remember, whatever catalyst you're adding, catalyst is used to fasten the reaction so that the speed of the reaction is increased. Okay, or if you are talking about the pressure condition, or if you're talking about the temperature condition, you can mention these things over the arrow. Okay, now in the second equation, you all can see how the glucose is formed. You all know the conditions for it, right? Carbon dioxide gas should be there and water is provided, and you all know that sunlight is used, right? And that is how the glucose is formed with the help of chlorophyll also, right? So glucose is formed here, oxygen is given out, which we use, and then water is also lost, right? So in this equation, you can see sunlight, because it is a necessary condition. You know that even if sunlight is not there, this process is not going to take place. Sunlight is very important for this, right? And chlorophyll is met. So that means all the necessary conditions required for a reaction to take place, we can write them over the arrows. Okay. So this was left, otherwise we've discussed all the other part of this one. We'll be discussing these questions once we are finished with this chapter. The index question and the NCERT question, I will be taking a longer session for one day, and I will complete all the index and all the NCERT questions in one go. And that day maybe we can go live also, all the students can join, and then we'll be doing these questions. Now, we will be talking about the type of chemical reaction. You know that like every person have a different type. Some person is very jolly, some person have a different kind of ego in them, some kind of person have another kind of nature. Like every person have a different kind of personality, right? In the same way, if you talk about the chemical reactions are of also many types. Like we humans are of many kinds. We have different heights, we have different weights, we have different complexions, we have our different interests. In the same way, chemical reactions are also of many types. So the word itself is telling us the first one is combination reaction. Combination means combining of something, right? If I'm talking about this is reactant A, this is reactant B, they both are combining to form one single product. So this is combination reaction, simple, easy one. Combination means combining of two things, right? So this is the combination reaction. Now, we'll be talking what all is going to happen in a combination reaction. Now, see, I'll tell you one thing related to this equation. Just give me a second. This equation which is written here, this is quicklime which is used on the walls. If I tell you about this paint, this is a quicklime powder which is mixed with the water to make it a slaked lime. Slaked means having some water content inside, okay? And then it is applied over the walls. So the white color, I'm not talking about the paint. It is called quicklime. Quicklime is a different thing. In Hindi, it is called as putty, okay? So quicklime is CaO. So quicklime, when you are mixing this powder with water, we should never touch it with bare hands, and it is going to give us CaOH 2 times, which is slaked lime. This is quicklime. This is quicklime. That means the putty which you are going to buy from the market, that will be quicklime. And when you will mix that with the water, it will become slaked lime. Okay. And if I've applied it over the wall, after that, this that you have applied. This is there on the wall. Okay. And let's say you might have seen after the slaked lime is now covered, your walls are covered with the slaked lime. After 2-3 days, we don't paint that wall, right? For 2-3 days. Why we don't paint that wall for 2-3 days? The reason is because the wall is now going to do another reaction, and we are not even aware that that reaction is taking place. So this CaOH 2 times, that means the slaked lime is going to react with the carbon dioxide present in that room, and it is now going to give us CaCO3, that is calcium carbonate, which is also a formula of marble. And that is the reason after 2-3 days you see that the walls start shining. This is because of this, okay? CaCO3 is also the formula of marbles. And now whatever is left will move out. CaCO3 is written and H2O will be given. I hope that's clear. And this is the reaction which happens at our walls. I hope it's clear to everyone. Now see, why am I calling this reaction as combination reaction? Let's say this is CaO, this is calcium oxide. Okay, that is quicklime. This is quicklime and this is water. So they both are reacting to form now a slaked lime. That is this one, right? Because two things are combining, it is a combination reaction. And always remember why I was telling you not to touch the slaked lime with the bare hands, because when this reaction takes place, it is an exothermic reaction. What is the meaning of exothermic reaction? Some of the students get confused that, ma'am, when to use exo and endo, which one is going to give the heat out and which one is going to take the heat in. So just simply learn one thing, that exit. Exit means go out, move out. So exit and exo, same. So in exothermic reactions, the heat is going to go out. Heat goes out, okay? Out of the container where the reaction is taking place. And if you talk about endothermic reactions, we'll be talking about both type of reactions later also. Endothermic, enter. See? Okay, enter. So when the heat is going to enter, that means you're using the heat, that is endothermic reactions. But when the heat is moving out, that is exothermic reactions. I hope that's clear to everyone. Now, okay, yes, this was the one which I was telling you, right? A solution of slaked lime produced by this reaction, which we have discussed, is used for whitewashing the walls. Calcium hydroxide reacts slowly with the carbon dioxide in the air to form a thin layer of calcium carbonate on the walls, and this calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to know that chemical formula of marble is also CaCO3, and this is the reaction which is taking place there. Okay, and some heat is also released during this reaction. Now, okay, now see, some more reactions are there which are exothermic, which are combination. Now you know that burning of coal. What is coal? Carbon. Coal is completely made of carbon with some impurities, right? So when you're having carbon and you're burning carbon, you know that oxygen is a facilitator for burning of anything, right? So the product form will be carbon dioxide. So this is again carbon, oxygen combining together to form carbon dioxide. So this is again a combination reaction, right? Now you're having hydrogen gas combined with oxygen gas. So it is again going to give you hydrogen plus oxygen is going to give you water, right? But this equation is not balanced. Why? See, oxygen is 1 on the product side, but on the reactant side it is 2. That means I need to balance this reaction. So to balance it, can I write it like this? Now it is balanced, right? This is how you balance the reaction. Okay, now let's move further. Next is burning of a natural gas. You all know that a natural gas is methane. Methane is a natural gas, always remember. Methane is a natural gas. The formula of methane is CH4. I'm saying burning of natural gas. This is natural gas. Burning means facilitator will be required, which is O2. So with this reaction, we are going to get carbon dioxide and water will be produced. Okay. When methane is burned in presence of oxygen, we'll get carbon dioxide and water. So we all know that we need energy to stay alive. We get this energy from the food that we are eating. And during digestion, food is broken down. Now we are breaking down the substance into simpler substance. For example, rice, potatoes, bread contains carbohydrate. These carbohydrates are broken down to glucose. This glucose combined with the oxygen in the cells of our body to produce energy. This special type of reaction you all know is this, right? Now, the decomposition of vegetable matter. Decompose means, now see, combination means to combine. Now it is decompose. If I say compose means combine, you know that the singers compose the music. That means the singer make the music by combining different words. That is compose. So if I'm saying decompose, you're having a complete song which is composed and you're now decomposing it. That means you're taking out each and every word separately, right? So that is decompose. So if I'm having a reaction, let's say I'm having this. Okay, and if I am breaking it, I'm decomposing it. Okay, so it is going to give different products. It will give you this and this. That means it was earlier this, and because now you decompose it, it is going to give CaO, that is calcium oxide and carbon dioxide. That is, this is quicklime and carbon dioxide. I hope that's clear to you all. Now, decomposition of vegetable matter into compost is also an example of exothermic reaction, because you know, decompose, when you're having a vegetable matter. Okay, I'll tell you what is a compost. Compost it if you're having one closed surface area in which you are keeping some vegetable matter, some kitchen waste you have poured, and you can add some insects to this, like worms to this. There the production of decompose will start. Okay, so as it will start decomposing, it will also produce some heat. That's why it is called as exothermic. Exo means exit, so the heat will be given out to the surrounding, right? I hope that's clear to you all. Now see, this is decomposition. Decomposition means breaking. Compose was combine, decompose is breaking. So this time if I'm having FeSO4, that is ferrous sulfate. So always remember, when you are having FeSO4 and you're heating it, the symbol of heat is this triangle. If you're heating it, you will get ferric oxide. Okay. then with this you will get SO2 and SO3. Now see how you will remember. Sometimes the students say that ma'am, we don't remember the gases which are being released. So you can learn it in this way. This is 4. Then one gas will be released which is having 3 and 2. And see, this is SO4. So SO4, SO3 and SO2. This is it. This is on the reactant side. So 4, 3, 2. Reverse counting. 4, 3, 2. You're having SO4, SO3 will be released and SO2 will be released. Simple. Okay. So this is how you can remember it. So how we are doing this reaction? See, we are taking. Okay. One more question for you all. What is the color of FeSO4? If any one of you know what is the color of FeSO4, please comment down. Otherwise, in the next class, I will tell you all. Okay. Yeah. So we are having FeSO4 and we are heating it. So we will be getting the ferric oxide, right? And SO2 and SO3 will be given out as we already discussed. So we are taking 2 grams of ferrous sulfate crystals in a dry boiling tube. So this Bunsen burner was giving the heat to the tube in which we have kept the ferrous sulfate crystals. And as we are burning it, some gases will be released. And what are these gases? SO2 and SO3. And always remember, a question can come from here also, that what is the smell of these gases? So because they're having sulfur atom in them, the smell is of sulfur, which is pungent. The smell which is going to come is pungent smell. Okay. I hope that's clear to you all. This is about the decomposition reaction. Okay. Now in this reaction, you can observe that a single reactant is breaking down to give simpler product. So this is a decomposition reaction. So ferrous sulfate crystals, ferrous sulfate crystals have 7 molecules of water attached with it. These dot 7H2O means you will say that ma'am, it's a crystal, it is very tight. How can you say that water is there? But even if it is tight, always remember crystals have some water content inside it, because these atoms are these molecules are less, so they appear to you as a solid, but otherwise they have some liquid content. Okay, so for FeSO4 it is 7. Okay, now some of you say, ma'am, it's very difficult, how can we learn it, which one will have how many molecules of water? Again, I will show you this. Okay, you have to just do one thing for me. Just calculate the number of alphabets that you have. 1 second, one more, and how many times oxygen we are having? 4 times. Add all of them. So it is 4, 5, 6, and 7. So how many water molecules? 7 water molecules. That's it. That is it. Simple. Okay. So study smartly. So when you're going to heat it, when you're going to heat this, what is going to happen? Obviously, the water is going to get evaporated, right? So all this water molecule, all the water content will move out, and that is how the water loss when you're heating, and the color of the crystals will obviously going to change, right? So then it decomposes to ferric oxide with the evolution of 2 gases. I've already told you. In FeSO4, it is SO4, and the product side will be SO3 and SO2. Reverse counting from 4, 3, 2, like this. Okay. I hope everything till here is clear to you all. Now, this reaction I've already told you that if you're having calcium carbonate and you're heating it, it is going to give you CaO plus CO2. Okay, one more trick for you all. Always remember, whenever CO3 is there, on the reactant side, one product is for sure same in every reaction. Wherever you will see CO3 is CO2. When you're having CO3 on the reactant side, CO2 will be fixed on the product side. Okay, then whatever is left, just write it down. That's it. Okay, so this is again a decomposition reaction because this is CO3, and now because you're heating it, it is giving you 2 products. One is CaO and the another one is CO2. Okay. Okay, now this is it. Do we have anything else to discuss? Yes, we have, but now we'll be doing this in the next class. So I hope everything till here is clear to you all, and you all are going to like subscribe to this channel for further updates. And in the next class, let's see what all will be finished. This part, decomposition will be finished and displacement will also be finished. That means 1 more class and then we'll be done. That means two more are required. Okay. So this is it for today. I hope you all have enjoyed today's session. Now we'll be meeting some other day with some another great session ahead. Till then, take care. Bye-bye all of you.